Hey y'all, it's Mr. Boyden. I'm back at it again. Today coming to you from my house. And today we're going to be talking about surface area of different solids in geometry. Now, why would we care and why am I actually in the video today and why can you actually see me? Well, it's because I think I need to show you what some of the applications are before we learn about it. So what I want you to think about with surface area is it's like asking how much paper does it take to cover something or how much paint or something like that. So I've got a few simple examples here that I want to show you. The first one is just a simple can of beans. With this one, with surface area, we would want to know, like, if we're producing a product like this, we would want to know how much surface area does the can have because that's where the label is. And so how would we think about that? Well, if you take the label off, the label is actually a rectangle. Well, that's really easy to find. So we can measure the height of it. We know the height to find that area. We need to know the base. The base, since it wraps around the can, is a circumference. Okay, so that's something we're going to see today with how to find the surface area of a cylinder. In this case, we're not worried about the circle on top because it's not covered by the label. We're just worried about this lateral surface, what's that called, the surface on the side. Okay, another example of a cylinder. In this case, it's some salt, and in this case, the paper goes all the way around. So we would need this lateral surface area, but we would also need to find the surface area of those circles. It's easy, just pi r squared. They're not always cylinders though. So I was just looking around my house for an object that was not a cylinder, and I came across this triangular prism that was given to me by a friend right when I first started teaching. So with this one, it's got a bunch of different faces. We've got the back, which is a rectangle. We've got the base, which is a rectangle, but the ends are triangles. So the way we find the surface area is still not very complicated. We just identify all the shapes. So I have a rectangle, a rectangle, a rectangle. I need to find the surface area of each of those. It's pretty easy, base times height. And then we need to find the area of each of the triangular bases. Now this solid has 5 different faces, 1, 2, 3 around, and then 2 ends. We just add those 5 areas together, and that's the total surface area. If you wanted to paint it or cover it, or in this case, you'd probably put like a clear coat on it so that it doesn't get damaged, or maybe you put a wood stain on it or something like that. Okay, now those are all really small examples, and maybe they don't feel super tangible. So how would you use this? Because, I mean, unless your name is Campbell, you might not be designing soup cans, right? So how would you use this? Well, I don't know how you're going to use it. There's a couple ways that I have used it. First one is, about 5 years ago, I wanted to paint my house. And I found out that by painting it myself, rather than paying a company to do it, I could save thousands of dollars. And that mattered a lot to me. So I went around my house and I calculated the surface area of the whole house, because when you go to buy paint, they tell you how many square feet a can of paint will cover. And that allowed me to buy the right amount of paint. If you buy too much paint, that's a problem because you can't return it. It's custom tinted for your house. And if you don't buy enough, it's just a hassle having to go back and get more, especially when all the brushes and rollers are out and the house is already prepped and things like that. Okay, so we're going to look at a couple other examples of like what the purpose of surface area is. Then we're going to run through a couple of calculations, and that's going to be our learning for today. So let's get to it. For a few other examples, let's consider these. Okay, these come right out of a book. We'd want to know the surface area in each of these instances. On the far left here, we've got a skyscraper, and it looks like all the surfaces are covered in glass. So that would give you a really good idea as an architect or as a designer how expensive it's going to be to cover this whole building in that glass. Second one, famous museum, the Louvre in Paris. Again, glass covering, but this time it's a pyramid, so you're finding the area of all those triangles to figure out how much glass is going to be needed for the structure. In this one, we're talking about the roof. Usually you pay by square foot for the amount of roofing that you need. And if you're a roofing contractor or a roofing company, you want to make sure you bring the right amount of roofing material to a job. And what's interesting about this one is the shapes sort of get cut off a little bit. They're like up here at the top, you've got a triangle, but that triangle doesn't go all the way down, doesn't look like at least. It gets kind of chopped off right here. So you've got this triangle that's missing here. Over here, there's a little bit of the shape that's missing. And then up at the top, we have a cone. That's something we're going to learn about today as well, is how to find the surface area of a cone. And then here's one, looks roughly like a cylinder, and this one's made of brick, so you'd be looking for the amount of brick that it takes to do a facade on this building in Copenhagen. All right, let's get to some examples. Okay, let's do an example of a rectangular prism. So As I was saying earlier in the video, all we're going to do is we're going to find the area of each of the faces. So I'm going to start with the one over here on the left first. That's 3 by 6, so this is 18 square meters. Because it's a prism, the opposite side is the same, so this one's going to be 18 as well. What about the base? The base is 6 by 8, so that's 48 down on the base, which means the top is 48. So maybe I'll make an accounting of what we have so far. So we have 18 plus 48 for the top, plus 48 for the bottom. Now we need to do kind of the right and left sides. So it looks like this whole the whole container is 3 meters tall. So this face is 3 times 8, so that's 24, and that has an area of 24 because these are just rectangles. So plus 24 plus 24. Let's add those all together. And I get 180, and it's square meters. And these look like they are painted. So in this case, maybe what we're interested in finding is how much paint does it take to cover one of these shipping containers to keep them from rusting? Because from what I understand, they possibly could rust. Okay, so that's our first example today. Kind of a simple one. Prisms are usually pretty straightforward. Let's see how they get a little bit more interesting. Now we'll look at a cylinder. Okay, now if we're going to find the surface area of the cylinder, and notice they didn't tell us if we're finding the top and bottom, so when it's just a math question, we do assume that they mean all of the faces, not just some of the faces, like with the soup can. So what we're finding here is we need to find the area of the top, of the bottom, and then what's called the lateral face, which is just that rounded side. So I'm going to put LF here to go short for lateral face. If you wanted to call it the side, that's totally fine. And remember, we showed with the can of the garbanzo beans that this shape is actually a rectangle. Now what I like to do is start out the question by identifying what is that I'm finding. I'm finding the top and the bottom and the lateral face, so I've written that all down. So how do I find the area of the top? Well, it's a circle, and it has a radius of not 10, that's the diameter, 5. So that's pi r squared. Except I shouldn't be writing r, I should be writing 5. Now notice, the top and the bottom of the cylinder are the same shape. So there's 2 of these. So I'm going to multiply it by 2. So we have top and bottom encompassed right here. What about the lateral face of the solid? So we said that was a rectangle. Remember, rectangle is base times height. The height is the easy part. That's 12. But in the case of a cylinder, the base is the circumference. So the circumference all the way around, remember, circumference is 2 times pi times radius, or pi times diameter. I'm going to use pi times diameter because the diameter was given. So that would be 10 pi multiplied by 12. So let's type that in the calculator. Let's see what we get. I'm going to do it in the answer in terms of pi. Now I'm noticing that a lot of you still want to round all your answers on everything to get a decimal. We also want to make sure we know how to leave our answers in terms of pi. So here I go. 5 squared is 25. 25 times 2 is 50. So that's 50 pi. Plus 10 times 12 is 120. And there's still a pi. And I add those together and I get 170 pi square inches. Now, if I was going to the hardware store, going to the paint store and buying paint, I'd multiply that out. And so you know what? I better do it right now just to make sure I still know how. So 170 times pi, and it rounds to 535 square inches. So we want to make sure we know how to get both of these answers. How would it be different if we were finding the surface area of a cone? The cone is a little bit harder to think about, but we have a visual here to help us understand a little bit better. So what we're looking at in this middle picture is if this top part of the cone, imagine like a birthday party hat, if we cut up the edge of it, and then we open it up and fanned it out, okay? And then in order to put it back together, you'd kind of pull this point and this point together, and then usually staple or glue it together, okay? A couple things that we need to get out of the way here for vocab. 2 pi r, that shouldn't be too surprising. That's the circumference. That's saying all the way around this circle, so it's all opened up. And then this L right here, that stands for slant height. And this is something that you probably need to add to your notes, that we call that the slant height, if you've never heard of that before. And that is the letter L. And that's different than the height. So in a cone, the height, and I think this came up a little bit when we talk about volume, the height goes straight up from the center to the tip, and it has to make a right angle. But notice right there, this slant height's not making a right angle. How do you know which one is the slant height? Well, it goes from the base to the top, but it's slanted. That's why they call it that. Okay? So what they're doing here is to get from this picture to transition over to that one, we're taking each of these triangles, because notice it's just a whole bunch of triangles, and we're rotating them and rearranging them in a fashion so that they fit together. They actually make a perfect rectangle. Well, that's interesting, because for a rectangle, all we need is base times height. But now that we've rearranged it in this way, because we've got half of these down here, half of these bases, we have pi times r instead of 2 pi r. It's half as much, because the other half is up here. And then our height on all these is L. It's right there. So you can see it vertically right there. So when we look at the area of the rectangle, base times height becomes pi r L. So let's add that to our notes. The surface area, or I should say, what I should say is the lateral surface area, because it doesn't include the base. Lateral surface area of a cone is pi multiplied by the radius multiplied by the slant height. Please pause the video if you need to. Get that down in your notes, because that may be a new formula for you. It's a simple one to use, but we want to make sure that you don't forget it. Let's see how it applies. Okay, pause the video if you'd like to. I'd actually like to encourage you to go try the example. So pause the video, try the example, and hit play when you're stuck or when you want to see if you got it right. Find the total surface area of the cone. So that means both the lateral surface area and the base. So I'm going to annotate that real quick. So we have the lateral surface area plus the base surface area. Now we learned a minute ago that the lateral surface area was pi RL, so I'm going to write that out. The base is a circle. The area of a circle is pi r squared. So you see how I've already set up this equation? This is something I didn't necessarily do as clearly in the other examples, but if you're struggling, start out by writing it in words, because most people can get that. Then translate your words into equations, and then plug in some numbers. So here we go. So pi times the radius, they gave us the radius, that's 5. Slant height is 10, plus pi times the radius squared, so that's 5 squared. Let's multiply this all out. That becomes 50 pi plus 25 pi, so we get 75 square centimeters. And that's it. Let's look at another example involving a pyramid. In this case, they tell us that it's a square pyramid. I'm really glad they said so, because otherwise there's really not a way to solve it. And when they say square, that didn't necessarily look square to me, but if they say it's square, if this is 5, that also tells me this base is 5. So we're going to use the same technique that we've used all along. We're going to break down this solid into all of the individual shapes that make up its surface. And what is that? That's 4 triangles, a front, a left, a right, and a back. So 4 triangles plus a square on the base. And I want to encourage you, unless you're just absolutely getting these quickly and easily, you need to write this out every time. Write down, it's a little accounting on what shapes we're adding up. So if we know the area of the triangles, so I'm going to turn this into equation now. We know a triangle is base times height divided by 2. And a square, you could say base times height, or you could just say like side length squared. Either way is fine. We can probably plug in all this information now. So let's look at each shape. For the triangles, let's keep the 4 there. Base is 5, and it's 5 on all of the triangles. The height, they gave that to us. That's 6. That was awful nice of them. And then 2 down there. Plus the base, so that would be 5 squared. Let's calculate this out. So that would be 4 times 30 over 2 plus 25, which would be the same as 4 times 30 divided by 2, which is 15, although I don't know why I wrote it so small. That's kind of strange. So 15 plus 25, 4 times 15, that's 60 plus 25. So we get 85 square centimeters. So look, y'all, that's all the basics. All you're going to do is find all of the different sides, identify what they are. We did that right up here. Write down the equations for their areas, and then plug in the numbers and simplify. That's pretty much how it goes. Now, there is a way that it can get more challenging, though, and so I want to look at that with you now. And that would be if we had something called a composite solid. And so that's what we're going to look at in this example. Here we have an example of a composite solid. And to me, when I see this, it looks like it's a birdhouse to me, especially if it's 30 centimeters side to side and a little hole. Looks like maybe it's a birdhouse. And maybe we want to paint the birdhouse or stain the birdhouse so it lasts a long time, because if a bird makes their home in it, we don't want it falling apart, do we? So let's figure out how to find the surface area of this birdhouse. I think that this is going to be easiest if we're really intentional about how we organize our information. So what I'm going to do here is I'm going to break this into really two problems. And I'm going to call mine roof and house. I mean blue for the roof, and I mean the green part is the house. Okay, so the green part's down here. And I'm going to break it down into two problems, and then break those problems down into smaller problems, and then add them all together. Now, it looks to me like one of the easier things to do is going to be the house part. It looks to me like the house is going to be the easier part to figure out, so I think that's where I'm going to start. I'm going to zoom out just a little bit so I have enough space to write over here. And so one thing I do need to do before we start is we need to decide, and because this picture that I chose didn't happen to label it, so I need to choose a diameter right here. I think I'm going to choose 10 centimeters. Okay, just choosing a number. Okay, and that's something you would never be asked to do in a math question. In real life, you just measure it. Okay, so for the greenhouse has sides, so left and right, and they've labeled that as 18 and 24. So that's 18 times 24, and there's two sides, so I'm going to multiply that by 2. There's the back of the house. How is that? So this house is 30 across, so its base is 30. The height of the house is 18, so that's 30 times 18. What about the front of the house? The front is also 30 by 18, but there's a catch. There's this circle missing right here so the birds can come in and out. And you're not going to paint a hole. There's nothing there. So we need to subtract that off. So we need the area of that circle. Now remember, circle is pi r squared. And this one is going to be pi times, not 10, 10's the diameter, pi times 5 squared. Okay, so we get all of those set up. I got my setups there. And you know what? I'm kind of looking for a win, although you know what? It dawns on me, I also need to do the bottom of the house part. I missed that. So the bottom is 30 by 24. Okay, and so we've got all of those set up. Now, notice I have the sides, the front, the back, the bottom. I'm not including the top because there's no evidence that a top portion here is painted if it went like that, because there's a roof over the top of it, and it probably has a vaulted ceiling in there. So this is going to be my set of calculations for the green part of the house. So let's get those done right now. This part of the problem will be done. And so I'm going to take a minute here and pause and just type all of these in my calculator to get the answer. And when I type all of that in, I get 2,153.46, and it's centimeters squared. I'm going to leave that decimal there for now. I'm probably going to round it a little bit more at the end, but I'm not done yet. Okay, that was just for the house. Oops, I missed for the house part of things. Now let's go look at the roof. Now I actually chose the house first because it had that hole to subtract, which means in my opinion, it's a little bit harder. So with the roof part, let's identify the different parts. We have the top of the roof, and then we have the front and back parts of the roof. Now, one of the nice features of this one, the way they designed this birdhouse, is that the two halves of the roof are exactly the same. And so let's try to set up our equations for that. For the top of the roof, there's two parts, and they're both rectangles, so it's going to be base times height. So let's try to fill that in. That'd be 2. I'm going to call the base 17. And then the height is this, and look, it matches right there. So that's 24. So that's our calculation for the top. So we have both faces, so 1 and 2 you could call them. Okay, I'll get rid of that so it doesn't look like measurements. And then there's the dimensions. Now we need the front and the back. It turns out that the front and the back are the same. There's two faces, front and back. And we need their base and their height. Well, the base is 30. We can see that down here. And so that base of the triangle, I'm looking at this whole triangle here. And the height they gave us was 8. That was super nice. So base times height. And then it's base times height divided by 2. Now the easy thing about this, these 2's are going to cancel out. So I'm going to call this roof total when I add these two together. So I'm about to do the calculation here and here, and I'm going to add them together all at once just so it's quick and easy. So let's type that in. 2 times 17 times 24. We're going to add that to the result of 30 times 8. And I got 1,056. So, zooming out, we broke this down into two problems, a roof and the house part of it. And I need to add those two results together. So let's do that. So plus 2153, I'm going to round to the nearest whole. And so I get a total surface area of 3,209 centimeters squared, or square centimeters. Okay, so that's an example of a more complicated problem. That starts to hint at what it was like. You can start to understand what the experience was like for me finding the surface area of my house. For example, one of the challenges I had, the front of my house, like many houses, has a garage. And so my house goes like this. And so in my case, I had to subtract off the garage. And actually, to complicate it, if you really want to get into the weeds, I put a different color up here than I did down there, kind of like on this birdhouse. So I had different calculations for different kinds of paint, and I think you can start to see how this would become useful in planning out a big project like that. All right, guys, I think that's going to be enough for today. Hopefully you enjoyed the video, and I'll see you next time.